So the division of polynomials can give us some information about the polynomial itself. For example, if we use the remainder theorem, if we know we have a polynomial f of x and we divide it by x minus c, then the remainder is the function value at x equals c. So this remainder is going to give us the same remainder we would get if we divided the two, or if we divided f of x by x minus c. To do this, we're going to use synthetic division because it's faster and it's easier to use. If we want to find f of 2 for this function, rather than plug in 2, we're just going to write out synthetic division with all of our coefficients, 1, 6, negative 12, negative 30, and 35. Bring the first number down. 1 times 2 is 2. 6 plus 2 is 8. 2 times 8 is 16. Negative 12 plus 16 is 4. 2 times 4 is 8. Negative 32 plus 8 is negative 22. 2 times negative 22 is negative 44. 35 plus negative 44 is negative 9. And so f of 2 is just equal to negative 9. We could do the same thing for f of negative 7. We're just going to do synthetic division. We're going to use negative 7. Bring down the 1. Negative 7 times 1 is negative 7. 6 plus negative 7 is negative 1. Negative 7 times negative 1 is positive 7. Negative 12 plus 7 is negative 5. Negative 7 times negative 5 is positive 35. Negative 30 plus 35 is positive 5. Negative 7 times 5, negative 35. And this one adds to 0. And so this function value is 0. This also means that when we divide f of x, this function, by x minus c, so in this case x plus 7, when we divide by x plus 7, we get a remainder of 0, which means x plus 7 is going to be a factor of this polynomial. And so this is what's known as the factor theorem. If the function value at c is equal to 0, then x minus c is a factor of f of x. Likewise, if x minus c is a factor, then the function value at c is equal to 0. So we're going to use the factor theorem to determine if these polynomials are factors of this polynomial. We're going to use synthetic division. We have x minus 3, so if this is x minus c, we want to use positive 3. And then we're going to write our coefficients, 1, negative 1, negative 11, 11, and 12. Bring the first number down. 3 times 1 is 3. When we add, we get 2, and then 6, and negative 5, negative 15, and negative 4. 3 times negative 4 is negative 12, and we're left with 0. So that means x minus 3 is a factor of this polynomial, because the remainder is 0. We can repeat the same process for b, except now we want to use negative 2. 1, negative 1, negative 11, 11, and 12. Bring down the 1. Negative 2 times 1 is negative 2. When we add negative 3, which gives positive 6 and negative 5. Notice this is much faster than plugging the values in or doing long division. Negative 2 times negative 5 is positive 10. This will give you 21. Negative 2 times 21 is negative 42. So if we're trying to determine if this is a factor, then we want this number here to be 0, this is negative 30, so it's not 0. So x plus 2 is not a factor, but x minus 3 is. So here we want to factor this entire equation, and then we're going to use it to solve for where it's equal to 0. We know that negative 5 is a 0 of f of x. So we can use that in synthetic division to break down the function further so that we can factor it and find all of its factors. So we're going to use synthetic division. Bring down 3. 3 times negative 5 is negative 15. When we add, we get 10. Negative 5 times 10 is negative 50, which gives negative 8. Negative 5 times negative 8 is positive 40, which gives 0. Which means we're left with 3x squared plus 10x minus 8. And we know here one of our factors is x plus 5, because negative 5 is a 0. We can use what's left over to factor the rest. This will factor to 3x and x plus 4 and minus 2. And so now our three factors, 3x minus 2 and x plus 4. And to find the zeros, we can take each one and set them equal to 0. X plus 5 equals 0, means x equals negative 5. X plus 4 equals 0, means x equals negative 4. 3x minus 2 equals 0, means x equals 2/3. And so now we have the factored form of the function and each one of the zeros.